Practice problem. This is centripetal acceleration for a planet. Okay, so now we're going to get really macro with our thinking. So refresh your page, Schoology, and let's do centripetal acceleration for the moon. Not really a planet, the moon. All right, the moon has nearly a circular orbit. I should say nearly a circular orbit around the Earth with a radius of 384,000 kilometers and a period, which is time, of 27.3 days. What is the moon's centripetal acceleration? The first step is to get a visual of our moon. Why is there a box around? Okay, let's leave that box. So draw yourself a circle. We'll call it the moon. The radius is 384,000 kilometers, and the time is 27.3 days. It's a really big piece of land. The first step is to find the centripetal acceleration, or a little c. And if you use the triangle, a little c is equal to v squared over r. And now we have to find velocity, because we don't have velocity in our practice problem. It just gives us the radius, the time. It's very similar to our previous problem, but these numbers are huge. They're days and kilometers. Now, in your waterfall, I asked the class, how do you reduce 1 billion into a number with less zeros? And many of you did an exponent, and that's correct. You want to use exponents to save space on your paper. This number is going to get so huge that you have to keep rewriting it, and then you might forget a 0 or 2 zeros, which makes a big difference. So we're going to make a calculator do all the work, all right? So everyone, let's set up our calculator to something called scientific notation that lets us use the exponents. So everyone go to the calculator and then click that blue button that says second. And then click that button right next to the second button. And you should see 3 options: flow, psi, or ing. Right, everyone following? If you don't do this, you have to rewrite the number that's really huge over and over. And that's going to take up all your paper space, and also you're prone to making a mistake when you write it. So I'll repeat that. On your calculator, click second, and then the button next to second that says DRG. Click that. It'll give you 3 options. I want you to go to the middle option where it says SCI for psi. Hit enter. And now your calculator should say 2 words at the bottom: psi and degree, or scientific and degree, right? If you don't have it, we'll know very soon, very quickly, that you don't have it like that. All right, let's take our knowledge of numbers and turn it into exponents. 384,000 is such a big number, it's going to fill up our paper. So we need to shrink it down. To shrink it down, you move your decimal towards the ones place. You want to move your decimal until it becomes a number, then a decimal, and then the rest. I'm sure your math teachers could word that better. But as a science teacher, I just know you have to move the decimal until it reaches the ones place. And it moves over 5 times. So that means you can multiply this decimal number by 10 raised to the 5th power. All right, so these two are the same thing. I'm going to repeat that whole thing. When you get a number that's really huge, you can shrink it down by moving the decimal to the ones place. So I moved it all the way over, make this the ones place, and now it's 3.84. The 3.84 and 384,000 are not the same thing. It's got to be as many times as you moved it, that's the exponent. Now, how do you put this in your calculator? You take your first couple numbers, and we'll always go to the hundreds. So in this case, 3.84, everyone hit that, 3.84. And then instead of writing times 10 and then raised to the fifth, you're going to click second, and then the number above 7, it says x minus 1. Second, x minus 1, and you should now see the letter E next to 3.84. This represents times 10. So not only are you saving room in your paper by using scientific notation, but also room on your calculator. So you won't get cluttered with too many symbols. So 3.84 E, and then put a 5. And now you've got the same thing here that is here. Now these kind of look the same in terms of how much ink you're using or how much lead. But you'll see later in our problem, it's going to save you a lot of space. We're just introducing the topic. All right, what's the third step to this problem? Because we have the first and we have the second. The third step is to turn kilometers into meters, because that's what the formulas require for velocity. Velocity is always meters per second. We have kilometers per day. Those numbers are too big. So the radius of our moon is 3.84 times 10 to the fifth. That is what we can write on our paper. In our calculator, it'll take up even less space. But to turn kilometers into meters, you multiply it by a fraction. Now, if you don't get why we do that now, you have to get it today, because we're going to keep doing this until December. Using fractions, convert units that you have to units that you want. So the units that we want is meters. So I'm going to multiply it by kilometers at the bottom, meters at top. The reason why, so they can cancel out. When I rewrite this, it's going to be 3.84. There should be an equal sign. Let me erase that. When I rewrite this, it's going to be 3.84 E5 times 1,000. Right, I just carried this over. And instead of writing times 10 from now on, I'm just going to write E5. Way easier. Times 1,000. So how do I do this in the calculator? Well, you already have it on your calculator. 3.84 E5. If you already cleared it, I'll repeat it. 3.84. Hit second. Then go to the number above 7 where it says E. Then click 5. Now click times 1,000. And you'll see it's a big number, but it puts it in scientific notation. Jack, what do you get when you multiply 3.84 E5 times 1,000? Times the 8th power. Jack would have had to written 384 and then 8 zeros after it. Okay, and that's not the final answer. He would have to rewrite that somewhere else. So instead, let's just write what he said. 3.84 times 10 to the 8th. And that's the same thing as 3.84 E8. 3.84 E8. And this is in meters. We haven't even plugged in for our equation yet. We just want these numbers to get smaller so we can use them in an equation. All right, that's radius. Let's do time now. Time is the days. This is the fourth step. We have 27.3 days. And we're going to convert it by multiplying it to a fraction. And I was going to do 1 day equals 24 hours, 1 hour equals 3,600 seconds. But we're running out of space. So let's just go straight to the point. 1 day has 86,000 seconds. 1 day has 86,000 seconds. So I cancel out my days, multiply across. I'm going to get a huge number, but our calculators will condense it for us. Let me ask Eduardo, multiply 27.3 times 86,400. Oh, it's not here. Let's ask someone who's here about Emiliano. Multiply 27.3 times 86,400. That's correct. 2.35. But we round up to 2.36 times 10 to the 6th power. And that was so much easier to write than writing 6 zeros after the number. Let me get rid of this 0. All right, we're halfway done with this physics problem. Now we have the units that we need to make the formula work. And these are seconds. So if you want to add a little s there, you can. In step 1, we had to find V so we can plug it into A. So the formula for V is V equals 2 pi r times t. So let me scoot this over. And if you're wondering where I got this, this is on our previous practice problem. Our previous practice problem, step 3. We plug in 2 times pi times 3.84 10 to the 8th, and time is 2.36 times 10 to the 6th. It's a good thing we converted these instead of putting the original numbers in, because that would not be meters per second. All right, let's just do one part at a time because you're new to scientific notation. Alexander has a calculator ready. Give me 2 times pi times 3.84, and then you're going to hit second DRG. No, sorry, second x minus 1. It's above 7. Second x minus 1, and then your calculator will say E, and then 8. Oh, I didn't. Good. All right, read it. What you got? 2.18. 2.1. 2.19. I get 2.4 something. Can you try one more time? 2 times pi times 3.84 e to the 8th. Yeah, you didn't go yesterday, right? Okay, are you in side? Does it say side? Does. And 8? Oh, 8.4. Oh, 8.4. 2 times 10 to the 9th. That's the same thing as 2.41 E9. And then we just carry over the bottom. And then someone do 2.41 E9 divided by 2.36. It's going to be Pedro Mendoza. 2.41. Second, x minus 1. 9. And then you can just click divide right after. Excuse me. 2.36. Second, x minus 1. 6. Try one more time. 2.41 E9
divided by 2.36 E6. E3. Good. I like how he used E3.
So it's kind of like a new language now when you want to summarize huge numbers. And sometimes it's not helpful to have E whatever. Like if the number's really small, you could just write that. Like if it's 50, you don't write 0.05 times 10 to the 2 or 3. Just write 50. But in this case, it's very useful. So let's keep going with it. 1.02 e to the third. This is only velocity, but we're almost done. Our sixth step is to plug into our acceleration, centripetal acceleration. And that is AC equals v squared over r. And that's going to be 1.02 E3, Pedro found that for us, squared divided by 3.84 E8. Carolyn found that for us. So we'll just do one part at a time so that you get used to it. Caitlin, grab a calculator and put in 1.02 second x minus 1, so you get that E, 3, and then you can just click square right away. The calculator knows not to square the 3, but instead to square 1.02 E3. All right, so don't worry about squaring the wrong thing if you put square right after the 3. Go ahead and hit equal and tell me what you get. Sure. Grab a calculator, put 1.02, and then hit the second button in the upper left. Then hit the x minus 1 button above number 7. And then your calculator will say 1.02e, which is the same thing as 1.02 times 10. And then click 3 because it's times 10 to the third. And then click square next to the 7. Right? E to the 6th. Good. And now the last step, divide it by our huge number at the bottom. It's going to be, Brandon, 1.04 e to the 6th divided by 3.84 e to the 8th. You know how to put it in? Okay. Did you get 2 something? 2 point. Say the whole thing. Look, it's not regular 3. There's huge difference between regular 3 and negative 3. This is a tiny number instead of a huge number. So this is good for really, really huge numbers and really, really tiny numbers. But that's how fast the moon is coming at us per second squared. Fortunately, it's trying to get away from us every second also. But then the Earth pulls it back. And the moon tries to get away, and the Earth pulls it back. Tries to get away, Earth pulls it back. Over and over. For millions of years. There is a third physics problem, but this is a lot. I think it's a lot to take in. And I have to make sure it's very clear how to teach the third problem. And I was really muddling with it during the DVD. And I think it would do more harm than good to have you do the third physics problem today. We can do it tomorrow, though, after you're iReady. All right, your practice problems are not on a worksheet. They're going to be on Schoology. So if you want a separate sheet of paper so you have your notes on one side and the practice problem here, you just raise your hand. I'll give you some practice problem paper, but they're blank. So you can write both practice problem and your notes on the same paper. But some students like having one on one side, one on the other. Let's try, right? Okay. Paper. Stop record. Okay, anyone else need paper? Okay. So I'm just gonna release one problem at a time. It'll be one practice problem, answer key, second practice problem, answer key. Now, many of you did not memorize your numbers. That's okay. I never made you memorize your numbers. I just gave you the paper that belongs to your number. But this is the front of the class, this is the back of the class. If your front left, you're 1. If your rear left, you're 2. If your rear right, you're 3. If your front right, you're 4. Okay. Think of this as like a car. The driver is 1. Passenger side, if you want to call it shotgun side, that's 4. And then the back seats are 2, 3. Okay. So that is your assigned number. And now you'll know which question you do in the practice problems. So I'm going to click practice problems. Go to the practice problem number 1. And then you'll see there are 4 assigned practice problems. So just do your own. I usually won't do this, but if I make it to the copy machine in time, I'll have these printed for you. But if numbers are up there, you match it to where you're sitting. If you're not sure, you can just raise your hand and I'll tell you. And then answer key will be posted in 5 minutes. But try this out by yourself and then check your answers. And then I'll post the second one. And then you can check your answers in 5 minutes. Oh, let's stop the recording.